This is Professor X, a fearless yet arrogant thief who has been committing robberies throughout the city. And this is the great Sherlock Holmes, who has pledged to nab the master criminal before he strikes again. Professor X follows a strange pattern while selecting the target of his robberies. He wants to inscribe his cryptic name all across the cityscape. Sherlock has gathered the coordinates of all robberies committed by Professor X. In case he's able to plot these points on a map, he won't just be able to analyze the pattern, but also pinpoint the location of the next robbery. If letter O denotes the origin, lying at the intersection of the two axes, how can Sherlock plot the coordinates of all previous crime scenes in order to arrest Professor X? We know that every point on a coordinate plane contains two components. The x-coordinate of a point is the value that tells you how far from the origin the point is on the horizontal, or the x-axis. Similarly, the y-coordinate of a point is the value that tells you how far from the origin the point is on the vertical, or the y-axis. If the x value is positive, the point moves x units towards the right side. If the x value is negative, the point moves x units towards the left. Similarly, if the y value is positive, the point moves y units in the upward direction. And if the y value is negative, then the point moves y units downwards. Using this knowledge, let's try to plot the first robbery, which took place at coordinates -3, 6. Since x equals -3 and y equals 6, we must shift 3 units to the left of the origin and then move up by 6 units. Similarly, the second robbery can be located by shifting 2 units to the right of the origin, then moving down by 4 units. The third robbery has an x-coordinate of 1 and a y-coordinate of 2. This means that we should shift 1 unit to the right of the origin and then move up by 2 units. In case of the fourth robbery, both the x and y values are equal to 0. This means that we don't need to move either left, right, up, or down. The same technique can now be used to plot the coordinates of all other robberies. In fact, things get interesting only when we realize that Professor X is just one robbery away from inscribing his name all over the city. Thanks to the symmetrical shape of the symbol, the x-coordinate of the next robbery will be the same as the x-coordinate of the very first robbery. And the y-coordinate of the next robbery will be equal to the y-coordinate of the last robbery. In other words, the next robbery can be viewed as a reflection of the first robbery across the x-axis, or it can be seen as a reflection of the last robbery across the y-axis. This also shows that the x-axis is equidistant from the first and the next robbery. Similarly, the y-axis is equidistant from the next and the last robbery. Confident in his prediction of the thief's next move, Sherlock sets up an ambush at coordinates -3, -6. It turns out, this is the Scotland Yard headquarters, where Professor X tries to steal the records of his crimes. But Sherlock, as always, is one step ahead and catches Professor X in the act. We have won the game of cat and mouse, at least until Professor X escapes from jail again.